In this video, we are going to demonstrate Geomagic for Solidworks. And for this video, we're going to show what we call hybrid modeling. Now, we've done another video where we show kind of traditional modeling within Geomagic for Solidworks, where we bring in scan data and we cut sections and we build sketches and extrude and cut and do different things. This one's going to be a little different, where we've got something that's very organic in shape, so you really can't do a lot of sketch-driven modeling. So we're going to do a command called AutoSurf, but then once we get that done, we will do some traditional modeling on it, more of your feature modeling or sketch modeling. So that's why we call it hybrid modeling. So to start with, Geomagic for SolidWorks is an add-on software product to SolidWorks. But what's really nice about it is it runs right inside SolidWorks. So some people know Geomagic has a product called DesignX, which is a very powerful reverse engineering tool, but it's a standalone product. So you've got to basically learn a different system. It's similar to SolidWorks, but it's different, and you're running it standalone. The advantage of this is it's all integrated in SolidWorks, and if you already know SolidWorks, it makes it very easy. So let's get started. So you've got this tab here for it. Now we can start two ways. We can click this button and actually have our scanner hooked up and actually do 3D scanning, and the data would appear right here in SolidWorks. For this case, we've already done the scanning, so we're just going to import it in. And what this is what's called a shoe last. And what a shoe last is it's used in the manufacturing process to make shoes. It kind of looks like your foot. And basically all the leather and the sole and everything is basically, it's wrapped around it and then, sewn or glued or whatever. Now this particular last is handmade, and we're going to make some changes to it and basically create a new one. We want to get it all digital and then, like I said, make changes to it. So you can see this is a very organic shape. And, if you were to try to, design this in SolidWorks, it's very difficult because it's, there's really nothing to measure. It is just, all this organic shape. So even with the Geomagic module here, cutting sections through it and trying to loft or extrude would be extremely difficult. Now, scan data is really just what we call polygon data. So I'm going to turn the edges on and zoom in. And you can see it's just triangles, okay? And depending on the scanner, or what density you're running at, you'll see, more or less. But it's a very dumb model. There's no intelligence to this. And normally, when you load this into SolidWorks, you can't do anything with it. You can't cut sections through it. You can't measure it. You really can't do anything with it. With the Geomagic plugin, it allows us to do a lot with it. Okay, so the first thing we're going to do is we're going to run a command called AutoSurface. Now, before we do that, there are a bunch of mesh editing tools. This mesh came in, it's watertight, meaning there's no holes in it, and it's ready to go. But we could smooth it, we could repair it, we could fill holes, and we can do some tools. But in this case, we don't need them. So we're going to go straight to this AutoSurfacing command. And I'm going to take the defaults, but just without going into too much detail, you can pick, how you want it to fit the surfaces. You can define a certain amount of patches you want, and then surface detail is basically how accurate you want it to try to fit to the mesh. So let's get it started. So what this is going to do is it's going to build a surface model. And it's going to basically build a surface patch model or a quilted patch, as some people like to call it. But basically, what it did, it just finished. Let's turn off the scan data. So let's just hide that. And let's come in here and turn on our edges. So this is a watertight, solid body that you see here. If it wasn't enclosed, it would be just a surface skin model. But since it's totally enclosed, it is a solid body. Now, it's not very editable unless we went back to the scan data and made changes to the scan data and then resurfaced it. But it is a solid body now. So the scan data was in a STL format or OBJ. Now, with this surface patch model, I can export this as an IGES, a step, a parasolid, which is typically what you need for manufacturing. So if I was done, I could now just simply export this and then have this thing CNC machine, or I could have an injection mold made if these were going to be made out of like plastic or something. Now, I want to go on and do some additional modeling, but again, this is what an auto surface model looks like, okay? Now, what we're going to do is bring our scan data back, and one of the things we can do in this Geomagic product is what's called an accuracy analyzer. What I want to do is I want to compare my scan data to that solid body we just built and see how accurate it is, okay? And it's going to give us this color-coded map, and if you look over here to the right, you can see the green is plus or minus 11 thousandths, and then if you were undersized, you'd see blue, and oversized red. Now, if you look at this, most of it is green, but you can actually see here we're seeing a little bit of blue, and that's because any real sharp corners, a surface model can't really create a sharp corner. So we're getting a little bit of undersizing, and we could go back and adjust that tolerance on that surface model if we want. But for our purposes, we look at this and we'll say, you know what, that's good enough. But we can use that to to check it to see if it's what we want. And again, if I turn off the scan data, you can see it tries to intelligently break up the surfaces at those sharp corners, but it's never going to be perfect. If you look at this, surfaces can't make a sharp corner; you have to break them. But overall, it does a pretty good job. So let's go ahead now, bring the scan data back, and let's hide that solid body. Because what I want to do next, and some of these commands we could do right on that solid body, but I actually want to show them on the scan data. So one of the beauties of this Geomagic for Solidworks is I can cut sections and do a lot of stuff right from the scan data. So what I want to do is I want to create a plane right here at this top, because that's pretty flat, so that'll allow me to do that. So what I'm going to do is I'm going to go into the reference plane command. I'm going to change my selection mode to, it's already set to lasso. And basically what I want to do is I want to just window in, basically just get some of this scan data, and you can see what it's done. It's highlighted in red what I've picked, and I can add or subtract to my selection if I want to add more or subtract. Let's add a little more back in. Okay, so normal stuff, but you can see what it's doing. It's going to average and fit a plane through that scan data, okay? So you can see what it's done. It's basically fit a plane through there. And then I can use this plane to do different things. Cut sections and do different things. I can offset it. So, just like you can normally in SolidWorks, I can offset down, because actually what I want to do is I want to cut down into the part here. So we'll just do an offset plane in this case. And let's turn off that top plane. So what I want to do now is I want to run a command called cross section, and I'm going to pick this plane, and you can see what it's doing. It's actually cutting a plane through the scan data and creating a sketch. So let's go ahead and take the default, and if we hide that plane, okay, you can see, let's hide the mesh, you can see this a little bit better. Okay, so it's built a what we call a mesh, and you see here it shows up in the tree as a mesh sketch. So it's like a regular sketch in SolidWorks, but it's construction geometry. So it cuts it and just creates a polyline, and it turns it into construction geometry, as you see here. So if I edit this sketch, I can actually come in here, and what I'm going to do, normally I would maybe build some other geometry for it. In this case, I'm basically just going to turn off the construction designation, and that just turns it back into a polyline, and then I'm going to exit out. And let's bring back our actual CAD data, okay? And what I'm going to do now is I'm going to use that section, and I'm going to go to a feature, because again, it's just like a normal section, and I am going to basically extrude. Let's go in the other direction, and let's try a 1/2 inch, because for my manufacturing process, I need, and I want to redesign this a little bit, I need this to be a little bit taller. Let's go 0.75. You can, basically do whatever you want. And we want to just merge the results. So basically, we're going to build more of a sketch-driven body, but we're going to tie it back into this surfaced, this auto surface model, so you can see what we get. So this is what we're talking about, kind of a hybrid model. So you can see we've added that extension to it, and it's all one body now. Okay. Now the next thing I want to do is I need a couple holes in the top here. So again, we go back to our sketch, and what we'll do is let's get to a top view. So we're looking at the top of it. Okay, and I want to put a couple holes in here. Okay, and at this point, again, I'm just sketching, so I can, let's make that a 1/4 inch, and let's put another hole here. Oops. And we'll also make that one a 1/4 inch. Okay, and I can move their location. Maybe, again, at this point, it's just your standard, SolidWorks commands. Let's make them 1.5 inches. I can't really, I can kind of estimate where I want them from the edges and all that, but because it's so organic shape. But hey, that's good enough for what I need. So now I've built those sketches, and now go back to our features, and this time I'm going to do an extruded cut, and I want to do both, and I'm going to go 0.25 inches, and there you go. So you can see I've cut those holes. So again, now we're doing more just your traditional, SolidWorks sketching at this point. Okay, so I need those mount holes on the top. And then the last thing I need, let's go, I'm going to turn on the front plane, and I need a slot up here through the base. So again, I'm going to do a sketch, and let's go look at that normal. And I need a 1 inch by 1/2 inch slot, and it just has to be approximate over here. So we'll make that 1 inch, and then this way 0.5. Okay, and you can see that's just kind of sitting out there right now. Go back to our features, extruded cut, and we just pull it through. We don't care how far. Okay, so you can see what that's done. Let's turn off that plane. And then the last thing I need to do, I need to fillet that edge. So we come in here and we just pick those edges. And you can see it, you just got to grab one of them on that surface. 0.1 is fine. Okay, so you can see we've done that side. Let's go ahead and do this side. So you can see the beauty of this. We're working on a very organic model, but yet at the same time, we're able to do more prismatic things. Okay, so there we go. That's all I need for this. So just to kind of wrap up, what we did was we brought in scan data, very organic in shape, no way to really feature drive it. Again, you could try to cut a bunch of sections and try to loft or, but it'd be very difficult. And we're not really going to change this organic shape. If we did, there are ways to do that with certain tools for mesh editing and then bring it in here. But we brought it in here. We auto surfaced it so that we get a watertight model. And then we cut some sections. We extruded up, more traditional sketch modeling, put a couple holes in it, and then also built the slot and radiused it. So now that we're done, we can go and export this as a IGES file, a step file, a Parasolid, any of the traditional CAD formats that you would share with somebody for manufacturing. So whether this is going to get CNC machined or 3D printed or injection molded, we can put it out in a CAD format that's usable. Okay, so again, it's a little bit of this organic modeling, and then some traditional modeling, and that's why we call it hybrid modeling. So just a quick overview of what hybrid modeling using the add-on product called Geomagic for SolidWorks.